So my name is Gabriel. I'm from Tallinn, Estonia. I work full-time with coin gaming, and my everyday life is working on the game distribution platform. And obviously, in one of those tasks, that is how I came about this experience, which I'm going to be sharing with you. So at the end of this session, I intend to share with you or describe in general processes, beam processes in action. Introduce Phoenix Jackpot, uh, a multiplayer game built solely on Gen7 states, that is the mechanics, and also share another use case for Gen servers or using Elixir within this industry. So what's the game that we are building? So Phoenix Jackpot is an engagement tool. Basically, it's just a gamification of some certain actions happening somewhere that we gamified. So it's a multiplayer game, and at the end of the game round, there can only be one player. So we have many players trying to achieve the same thing at the same time. At the beginning of the game, a predefined set of objectives shown here. So this is it. These are all achievements right here. These symbols I have right here, they are achievements, and we have a wheel. So every time it's very straightforward. It's just like a wheel of fortune kind of game where you spin a wheel and you get something. And if you get that stuff, if it happens to be one of the predefined objectives right up here, of course, this is activated and is persisted to the player's state. And these objects right here, these symbols, they need to be achieved in the specific order that they are defined. Meaning that at every point in time, when a player spins the wheel at random, they should have the next object. In this case, the next symbol that I'm expected to get if I am the player on this screenshot is the chariot. That is the current index where this wheel is positioned right now. Let's check out the game logic. So the game logic is as such. We have a set of predefined 8 symbols, which a player participating in this game round needs to achieve in the specific order that has been defined and displayed to the user. Every user gets the same set of achievements. So it's the same thing everywhere in every client that is connected to the game. So to win the game, you need to be the first player to achieve all 8 symbols, meaning that there are many players trying to racing towards one goal, and there can only be one player. So maybe at the end of the game round, there could be many players who might have taken up to 7 symbols, but the first player whose action is recorded first to have at the 8th symbol is crowned the winner of the game. And this poses a very big question. The 2 big questions that the presentation intends to answer is, how do we orchestrate this many player game sessions? And how do we determine the winner? If many players can all act or spin at the same time, we need to somehow be able to track the sequence or the series, the order in which we have actions from player and be able to choose one specific winner at the end of the game round. So our design. Let's consider the following big picture of the approach taken to set this up. As part of every OTP application, there's a supervision tree that is the root process to which that supervises every other process. For this, we give it an alias of the jackpot supervisor. The registry is quite obvious. The registry is just like a lookup place. That is, we have some process IDs stored there with some easy to find names that we can reckon with. And we need the registry because in this application, we have a lot of processes, a lot of player processes. Imagine we have n players. It means we need to keep track of n processes, which I'm going to share more as we go on. So the application startup, and the first process to be spinned up is the jackpot supervisor that is going to supervise every other supporting processes that we have in the application. So next, we have a game scheduler. So one of the features that we have in the game is that a game can be pre-configured to start at X time. This game scheduler is backed up with some storage where all these games are pre-configured, and if the time comes, basically the game scheduler start up the game. Starting the game means that in our case, for the purpose of this presentation, it means starting up a jackpot server. A jackpot server in this case is just simply a dynamic supervisor. Not to repeat the old documentation again, a dynamic supervisor is a supervisor that starts up with no children, basically. It means for this is just like the handler that is going to coordinate all our players that want to join the game. And the sole responsibility of our jackpot server is to keep all those player processes, track them, make them addressable, and keep them running, and also be able to apply the same action to all players or all processes directly under this dynamic supervisor. Together with the dynamic supervisor, we have another supporting process called the play queue. Remember, as one of the big questions that I posed forward earlier on is the fact that we need to be able to choose just one winner, meaning that we need some kind of mechanism in which we need to execute all player actions through it. For this, we have this play queue. The play queue is just a simple Gen server process that basically executes all our player actions on them, meaning that when a player performs an action on the client side, a message arrives, we address this message to a specific player, and the play queue knows how to find this player and execute such action on the player process. Now, let's imagine we have player 1 and 2, they want to join our game. Like I said earlier, the sole responsibility of the jackpot server is just to spin up and supervise new player processes. We have player 1 and 2 joining the game right now. So this can continue on and on and on until while the game is on, meaning that new players can join. All players don't have to join, players can join at varying times. And for this purpose, we can see how the dynamic supervisor fits so well into this kind of strategy. This can continue up to player n. And now the stage is set. We have our supporting processes running. We have a few players in the system. Let's say a user performs an action right now. The key action that you can perform within the game itself is just to spin the wheel. Let's say player 1 spins the wheel right now. One of the supporting modules that we have, the game service is just any other module that can perform an action, just some business logic within it. The game service basically gets the message okay, this guy spins. I'm going to discuss messaging in terms of mechanics to actual system messages later on in the subsequent slides. This player performs a spin. On performing a spin, basically the game service address this action to this player, sends and submit it to the play queue. End of story. We can already return a new game state to the client side. I will show what the game state looks like in the upcoming slides. In this case, now we have a message sitting right there within the play queue. The play queue, like I said earlier on, is just a simple Gen server, meaning that this message goes straight to the Gen server's mailbox. And this guy, all he's responsible for is just to execute every new messages, every new action coming from the client side, one by one, in the order in which they arrive. I'm making emphasis on these based on the fact that we need to be able to choose just one winner. And that is why the play queue becomes much more it's like a key component within the logic of our game in this sense. New message arrives, we apply them straight to the player processes via the play queue. In this case, like I said, the message is addressed, the play queue sees it, opens it up, looks up this player process via the registry, and can apply the action. to the player. Applying the action to the player, this I'm going to like flesh more down the line. Now, the whole big picture is clear. We just have a bunch of supervisors and some supporting processes, all OTP stuff. So let's check this out right now. The initial flow. How do players get to load our game client and even communicate with the game engine in the first place? So basically all client-side engine interaction happens via WebSocket in this case, in this regard. So let's say, for instance, a player through HTTP loads up the game URL. On loading up the game URL, we try to authenticate this user. The authentication is just basically token-based authentication. If your authentication is fine and everything is good, we set up a new game session, initialize the game state and the player state. I will make a very simple clarification right now moving forward, as this knowledge is very important. I will make a lot of references to game state and player state. The game state is just, you can think about it like a structure in terms from client-side perspective. Is just an object that contains like the current situation of what the state of the game is for this particular, a very specific client. And the player state is the containing structure where all the current situation of the player within on the engine side stays. So game state is the key structure that contains every response from the engine back to the client side, and the player state stays within the system. So now, for the purpose of like handling WebSocket messaging and every interaction that has to do with that, we used a WebSocket framework called Riverside. And one beautiful stuff about Riverside is like the implementation is quite familiar. It just looks like implementing like agent server, like in terms of the callback and the way like the handler is expected to be implemented. In this case, we just have, when a user tries to join the game, the authenticate method callback, if it is implemented, is called. On a successful authentication, the init callback gets executed. And what are we returning in terms of like initialization? On initializing a player state, what we do is just like we set up a fresh game state. And now I have the opportunity to explain what are all these keys that is within the game state. Like I said earlier on, game state is external, meaning that when we need to like communicate actions back and forth between the platform, that is the engine, and the client side. One point to note moving forward is like the client side. When I'm mentioning client side, I mean the game client. The game client it's a Pixie.js application, one of the frameworks to build like HTML5 games. And in this sense, I will just go to explain what each and every one of these keys mean. The symbol order is a containing object for. The symbol order is the containing object for all the symbols that we can see on the wheel. The achievement order basically contains the set of the 8 symbol objective in this sense. The symbol index depicts the current position, that is the index of the currently randomly selected symbol within the symbol order, the position where it is. And this is how the client side knows how to rotate or where to stop, basically. The achievement is a copy of just basically the internal state of the player process. How many symbols have this player has achieved based on the achievement order that is being defined beforehand. The players count. We can easily guess this. So basically new players are joining. Obviously we are broadcasting to the game client. When a new player joins, the client knows out like, okay, I'm going to increment this time. Well, yeah, maybe there are some lapses anywhere, or the client needs to use this information for something else. The players count is also within the game state. The user is self-explanatory. It's just the current, like the nickname of the current user that loads up the client. And this is the container or the response that a user that gets thrown back to the client side on a successful authentication. Obviously, if everything fails, there's not going to be any game state like a message gets displayed. But I'm just going to be considering the happy part in this presentation. I said the game state and the player state gets initialized on startup. What does the player state look like? The player state is a structure that is internal to the engine. So the user is self-explanatory. It's just the user, the nickname. The achievement is a map of all the predefined symbols that was pre-configured at the beginning of the game. In this sense, they all start with the initial value of false. And if a player gets to like spin the wheel and gets one symbol, fortunately, the wheel stops on one of the symbol contained within this map. The value of one of these keys gets updated to true. And it must be in that order, like 1, 2, 3, 4, 5, 6, up to 8. And actions is just like, so every attempt that a player makes to get one of these symbols is recorded embedded into the actions list, basically. So at the end of the day, we can replay the whole of the player's action, like everything can be replayed from start to finish. Now, we basically understand the two main artifacts for when a player joins the game, which two of them is just the game state and the player state. The achievement here is just a copy of what is shown. And this is how the client side basically keeps track of like, okay, this player has this, and this is the current situation of the game moving forward. In order to communicate between the client side and the engine, we basically need a mechanism. We need a predefined set of like command sets. We have more than this, but just for the purpose of this presentation, I just stick to these commands that are self-explanatory and kind of like straightforward. So the two commands there is like spin, meaning that when a user press the spin button on the client side, a spin message is sent to the backend through WebSocket. Let's consider a generic command flow. The generic command flow is such that we receive a spin like a worded command predefined. The socket handler receives this and just tries to resolve this command. It's either it can resolve it or it can't resolve it. In a situation that it can resolve it, again, we update the game state to show what the current situation is within the game and give the response back to the client side. And the client knows how to check all these keys and update whatever the visual effects and stuff for the player to see based on their action. And another interesting stuff, like I mentioned about the Riverside WebSocket framework, is that the implementation is quite similar, or it's quite familiar, like that, like those of the Gen7 callbacks. In this case, we have a handle message callback that gets called upon receiving new messages from the client side, and we can easily, if you have end commands, you can easily pattern match on all these commands and undo them through some other modules within the application. So in this case, if we receive a command, we just basically undo the message and reply back to the specific user that requested this command. And one of all the possible keys that can change in a spin command, for instance, is something like the symbol index. The symbol index could have changed. Maybe the player has achieved something, it could have changed. Maybe based on, like I said, is an engagement tool. Maybe based on some other activities that the player is performing, they have gotten some extra token to play this game. The spin balance might have increased, and so on and so on. This is the way that the client side can basically and easily keep track of what is the situation like for this particular client. So let's break down the spin command perfectly. In this way, through the socket handler, we receive the spin command just as it is. We handle it. There's an handler for it. And what happens within the whole application is that we try to make a randomized selection of a symbol within the set of all other symbols that has been defined. And we address this symbol as an action to the player, and we key it up. We key it up within the play queue that I mentioned within our big picture earlier on, where we get some more explanation as to that later on. And after it is queued up, we are going back to the client side right now. We check, is this the correct symbol? Is this the expected symbol that we are expecting right now? If it is a yes, we update the achievement. If it is a no, we don't basically, we don't change anything. We just specify the symbol index and just give the achievement as they have, return back to the client side. I laid emphasis on some keys here, which is the symbol index. The symbol index just basically depicts the position of this very symbol that is randomly selected within the entire set of symbols that exist on the wheel. And this is how the client side is not doing anything. This is how the client knows, okay, I'm going to rotate, and stop at this position. And the achievement is just like from symbol 1 to symbol n. It's just, what does this player have? And by the virtue of spinning, the spin balance of the player gets decreased, like it's like n-1. Like it's optimistic, like an optimistic update. It's like it gets returned back to the client side, and yeah, the client side can decrease the playing token of this player. Now, I mentioned in queue action. How does queuing up and applying an action to a player state, how does it actually happen? Thanks to our Gen7. You know, the Gen7 Mailbox, the Gen7 Mailbox out of the box works like, works in the FIFO-like manner. That is the first message that gets there. Although there could be some exemptions known, but in general, we can really take advantage of this behavior. By so doing, we can be able to stop the game if we need to stop the game at any point in time. So also we can be able to address the messages easily to the player, and we can be able to apply each action in the order in which they arrive. Remember, what we want to achieve at the end of the day is to find the player that will be the first to complete this task or this exercise, this set of objectives. In this case, enqueuing the action just simply means just sending the enqueue command or the enqueue message to the play queue, and the play queue just basically gets the message and tries to apply this message to the player state. And the only one thing that is within the play queue state is just this running key, this map that says running true or false. If we are running, we continue to enqueue the messages. If we are not running, meaning that if execute action right here returns false, it means like it means we found a winner actually. And in this case, we stop the game. We broadcast a general message to all connected clients like, okay, game over, we found the winner, and there's no need to do anything. And by so doing, we can be sure that we won't have two winners. There will be only one winner at the end of the day. So let's see what is really happening within this execute action method. To execute an action, enqueue, we already know we're just sending a message to the Gen server process. And in this case, to apply the action to the player, we look up the player using the user key within the message. Look up the registry, get the PID, send this play message to the player process. The player, this struct right here is just is kept within. Every new player that joins the game get a new process, and this is what is just kept within the state of such process. So to enqueue the action, on enqueuing the action, we apply the action to the player by calling the player process with this action, and the same thing. We check again, is this the next symbol? If it is the next symbol, we update the respective symbol within the player state like this. We turn it to true. And this can happen over and over, like to the point that the user like tries to like, we update each and every one of these achievements one by one as it is being achieved. We append that to the state and we update the achievement status. Let's say at the end of this update, if the update is completed, we do a second check. The second check that we do is to find out, has all the achievement been completed? If it is a yes, true gets returned back to the play queue. And that is how the play queue knows that, okay, I'm going to stop. I'm going to stop right here. If it is a no, of course, the play queue continues to include new messages and nothing happens, basically. In a scenario whereby we found a winning player, basically, the play queue broadcasts the message to all connected clients like, oh, I found my winner, and the game is going to end. And that is the end of that flow. The player gets rewarded and every other player gets the respective messages like a player has won, and you can try your luck next time. In recap, let's try to see the entire message flow, like how messages flow from within the process, just to explain like the process of actually playing to winning, so to speak. In general, a spin command gets sent to our socket handler. The socket handler is just an implementation of the Riverside WebSocket framework. And using the game service, making reference to that, is just an ordinary module. The game service basically address this message to a player, submit it to the play queue mailbox. And let's say, in this case, the first message comes like, happy part this time around. It's a true, we update, we give the response back to the play queue, another message comes back. So also so basically every message coming from the n number of players get executed in this such manner that you look up, is it the next one? Is it completed? Look up, is it the next one? Is it completed? So and so on until all the predefined number of n symbols that is expected to be achieved is completed. And if that is the case, on the last symbol, it means the game is over. It means there's no need to continue again, since we can only have one winner within the game. And that is basically the end of the entire game round or session. It was a summary. Why Elixir in the first place? I would say, like, in general, the key logic when it comes to like Gen servers, basically just, it makes this entire process like very, very easy, in the sense that like there's control in terms of like how. I know there's some other mechanism to achieve queuing or whatnot, but I think with Gen servers, like using the same tools that come out of the same framework, like really makes it important to and easy to approach or to think of or to reason with. And the fact that we have dynamic supervision also makes the idea of like orchestrating end sessions by end players much more easy, meaning that there's no strict requirement as to like, okay, start this time. It means that we can have new players joining on the fly, even when the game is almost close to our hand. And of course, the effect of the registry can be overemphasized in a situation whereby we have a web or like a very long list of n players playing within the same system at the same time. Looking up the process IDs and actually trying to find the actual respective process based on the action that is performed on the client side is much more easy with the registry. And I think at this point, I've been able to, to describe the process of actually like building a game engine with, depending on the mechanics. And of course, this is not limited, like this is the way it must be done. I think at the end of the day, what should we build with Elixir? The game engine we build with Elixir is a function of the mechanics of your own game. The key mechanics in our own game is just to spin the wheel and get some notification. So at the end of the day, it's much more comfortable to approach in this manner. And who knows what you will build. Thank you for your time. And I hope I've been able to communicate in one way or the other.
Thank you very much. So I've been observing the Hoover app for questions, and it seems that there's one right now, so that's good. If Wiebe Martin wants to unmute his mic so he can ask his question.
Okay. I think I can see the question. What are your opinions on using Phoenix PubSub for sending messages between players and the game servers? I think in this case, yes, it will equally work as well. I just used Riverside framework because like the game engine was just a like plain OTP application, not built on Phoenix. But if I need to remove just this one component, yeah, it's very, very achievable. Yeah, it will work.
Yeah, and
repository to look at? No, not at the moment. It's still internal at this point.
Yeah, so I think I have a question. So the queue process, you use the mailbox as the mechanism for storing the message?
Yes, in the play queue.
Yeah. Doesn't that present a problem with, for instance, using tools for introspecting the process if it's blocked because it's working as a queue?
I would say like there is no problem in this case per se, because in my understanding, if I understand your questions correctly, is you're coming from the angle of like, would this not like be a blocker when you need to introspect this state, right?
Yep.
In general, I will ask like, what tools are you looking at? Because like I think there shouldn't be an issue if I need to inspect this state, maybe through something like Observer CLI, for instance. If I get that correctly, I think there shouldn't be any problem if the process is blocked. And if the process is blocked, I think yeah, we are just throwing away like new messages basically. And at this point, I think the first point of failure for a specific client, the client stops basically. Like the client state is blocked and maybe the user needs to re-authenticate or restart a new session, so to speak, from the client side. And also another beautiful stuff that I didn't mention within the context of the presentation is that in a situation, I think I got this comment from an internal meetup when I first presented is like, okay, what happens in a situation whereby there's a restart or like there's an error within a specific player process? I think in general, like upon applying every action, we are also persistent to the database. So meaning that a player process could be restored if there's need to do so.
Okay. So we got another question on Hoover. Does a game engine with Elixir perform well compared to other game engines in your company? Which languages are the other game engines written in?
Okay, so basically we have engines written in Scala, Scala or just pure Java. I would say like in general, like I said earlier on, this very game engine is a gamified promotional tool, so to speak. And in terms of like comparing it as to performance, I think so far Phoenix Jackpot has not yet been to the biggest of all. Has not yet reached that level to start comparing it, like benchmarking it against other engines that we have, so to speak. If I answer that question correctly, yeah. I don't have actual facts. I don't have the facts, so to speak. Yeah.
Good enough for me.